But today we're going to be talking about Maricopa County's Floristic Quality Assessment. And we have a lot of the team here tonight who helped build this, as well as folks who actually initially developed this tool. So really, really exciting group that Juanita has gotten together for this project. And they'll talk quite a bit about what went into it, the background, how to use this tool, and I believe also some of Juanita's findings as well for Maricopa's parks. So just as a quick introduction to some of the folks who will be speaking tonight, this project was led by Juanita Armstrong-Alberg from Maricopa County Parks. She is the natural resource specialist there. And she does a lot of amazing work with CASCA in the parks, and of course, many of her own programs and research as well. This is one great project that I'm really excited to share with you all that she's been leading, and I think it's going to have some really cool impacts for our region as well. We also have myself. I should introduce myself for those who don't know me. I'm Ariana Rashke. I'm the program director for the Central Arizona Conservation Alliance. I just sort of helped Juanita reach out to a couple folks for this project, so I'm definitely not an expert on it. I'm also here tonight with Jenny Davis, who is CASCA's engagement coordinator. But among the other speakers that we have tonight to let you guys know more about this project is Linda Masters, the restoration specialist from Open Lands. We hope Jerry Wilhelm will be here from the Conservation Research Institute. I think he will. Juanita was talking with him. Oh, he's not, Juanita? Oh.
I had to leave a message. I didn't actually talk to him.
Okay, we'll keep an eye out for him and see. Let either Jenny and I know if he needs any help. But in any case, we do have Linda here. She's been pivotal in this work as well. Wendy Hodgson from Desert Botanical Garden was a big part of the project. She won't be speaking tonight, but we do have Kara Barron from Gila Watershed Partnership here, as well as Steve Jones. And Danica Sotero is part of the effort as well. I don't believe she'll be speaking tonight. Juanita can correct me if I'm wrong, but we have an amazing team here to share with you all what the tool is, how it works, and some stuff about already impacts and ways that Juanita is envisioning using this tool for our county. So I will hand off to Juanita and the team now. Thank you guys so much for being willing to share this with us. I'm really excited to learn more.
RJ's having trouble getting in on mine. Ariana, if you can help him.
All right, I'll see if I can help him out.
But Jerry's not. Okay, maybe just send him the link. Okay, so we're gonna get started. I'm gonna go down one slide. Linda Masters is gonna start us off, and then hopefully Jerry jumps on for a few minutes, and then Steve and Kara will talk a little bit about how we developed the county's database, and then you'll hear more from me in a little bit. So I'm gonna let you go ahead, Linda, and just let me know when you need me to move the slides. It's all yours.
Thank you, Juanita. Thanks, everybody. It's wonderful to be asked to help present this. I have a long history. Let me give you a little bit of my background. I worked with Jerry Wilhelm when we were both at the Morton Arboretum in Illinois, and I helped develop the very first computer program for this Floristic Quality Assessment method. Using, some of you will probably not recognize this, but we used Lotus 123 to get started. And I had to boot my computer up using 2 floppy drives. So that's when I got started in all of this. So stepping backwards now in time, I do have some familiarity with Maricopa County. In my early 20s, I lived in the Tempe area for about 8 years, but that was pre-botany days. So I have no idea what the plants are. I was there for other reasons that we don't have to go into right now, but I didn't know any plants. But since I moved back, Illinois is my home state. I moved back to Illinois, and that's when I began my natural resource career. So to get started with Floristic quality assessment, this tool was developed as a way to assess how to look at it in a natural area. When you're out in the field and you're looking at all these plants, what do they mean? What do those plants tell you? So it's a way to assess an area's ecological integrity. Jerry developed this in the Chicago region and the same process has been used for all the databases that have been developed. You make a list of all the plants that are known from a certain geographic region that's defined. And then you get together a group of experts who know the plants and can think about how they grow and what makes them grow where they grow. And these plants are then discussed, and then an agreed upon coefficient of conservatism, which is the second point here, is given to each plant based on, the numbers range from 0 to 10. And so each plant is given a C value based on how likely that plant will be found, how faithful, what's the fidelity or the conservatism of that plant to grow in a specific habitat. So a plant that's 0, we give all non-native plants zeros because they aren't part of a endemic habitat or natural habitat. We give plants, and then it goes up to 10. So you can give a plant from 0 to 10. 0 being non-native or weedy. You can find it in your backyard. A 10 would be something that is only found in pretty specific habitats. So next slide.
I'm here. Can you hear me?
Hi, Jerry.
Hi.
We can hear you.
Okay, I can't see myself. Maybe you can or not, but my whole internet went out for a little bit.
Technology. Well, I'm going to keep going with, can you see the slides?
I'll stop calling you now, Jerry.
What's that?
I'll stop calling you now.
You're calling me now?
No.
Jerry, put yourself on mute. Do you know how to do that?
My cell phone?
No, I'm sorry. I'll just keep going with the slides. That's what I should probably do.
I muted it.
Okay, but I'm talking about slide number 3, I think, right now. So anyway, so the question is, what does a floristic quality calculate in an inventory? So there are certain metrics that are, when you have a list of plants, there are certain metrics that you can apply to that list of plants. And one, of course, is pretty common. That's a species richness. How many numbers of species are in your list? And you can divide that up between numbers of native plants and numbers of non-native plants. So that's species richness. And then there's a total mean C, which is when you add up all of the conservatism, all the C values, you add them up and you get an average or the mean C coefficient of conservatism for all the plants in your list. And then you can divide that up between all plants and just native plants. So you can begin to do some math on that. The total FQI, or the Floristic Quality Index, you take the total mean C and you multiply it by the square root of the total species richness. And why you divide it by the square root of the total species richness is because that's a way to kind of temper the difference between large areas and small areas. Because large areas you would assume would have greater species richness. So that would just rank higher. But if you multiply by the square root, then that sort of levels out the playing field. So it gives smaller areas a better chance, or a better chance. Next, another coefficient is the wetness coefficient, is something that's a value given to these species to indicate its location on the hydrologic gradient. So that is something that number is supplied by another entity. And I'm not sure not all of the Maricopa County species have a wetness coefficient, and I'm not sure who gave that, but Juanita can speak to that later. It also it also provides physiognomic metrics. So it will tell you if the plant is a tree, a shrub, a vine, a forb, and so on. So you can then begin to look at, if you're interested in a specific type of plant that's growing there, it will tell you that as well. There's also duration metrics, annual, biennial, or perennial. It will tell you those. There's a little blurb at the bottom of this slide that provides a more lengthy description on the Floristic Quality Assessment Calculator, which I think this QR code, you can get to it through that QR code. Yes, Juanita's shaking her head, nodding her head, yes. Okay, next slide, please. So who uses the FQA? So, and there's sort of this is what some of the databases look like. A lot of different people use the FQA calculator. There have been 70 databases developed so far and uploaded. Many federal, state, county organizations, conservation, cities, etc. The U.S. Army Corps of Engineers have set parameters to determine performance standards for wetland mitigation. The beauty of this program, in my opinion, one of the beauties is that it allows people who are not botanical experts to be able to make informed decisions, because now people who don't know the difference between a daisy or an orchid can tell the difference now, because a daisy has a number and an orchid has a number. So they might not know the difference between what that plant can tell you about the area that it's growing in, but they know the difference between a 2 and a 10. That they know. So it sort of reduces a list. I'm not sure how many plants you have in your list, but it reduces all of the plants in the 2,000 plants. Let's say I'm just grabbing a number, to all the plants then go from 0 to 10. So it makes it much easier to make decisions. So this is an important tool for people to be able to make decisions, to arrive at performance standards, to assess, take a different kind of look at the areas that you're curious about or interested in. Next slide, please. So as I was saying, it's an important decision-making. What can we do with the FQA metrics? So it's an important decision-making tool for managing natural areas. So for natural area managers, you want to know, what is a site telling you? What is it? How does it compare to another site? If you need to make a decision between acquiring land, what would be, if it's sort of triage, if you have to make a decision, you can only buy one parcel, you have two, you can do an inventory assessment, see what's out there, and you can, it helps you, it's a tool in your tool belt to help you make a decision on, which parcel has higher priority. If you have an area and you have done an assessment and you know what is out there, and then all of a sudden a bulldozer goes through it, you can also then say, this is the quality of the land that was damaged, and this is what we need to do to make it better. Those kinds of decision-making processes. You can create baseline data. You can measure trends over time. The FQA calculator actually has two parts. We're focusing on the inventory assessment today, but there's a second part that's a little bit more complicated, but it's where you can put in transect information. So if you're interested in doing research on changes over time, I would suggest getting familiar with the transect part of the FQA, because that's where you can really begin to look at, if you're doing restoration or if you're trying to implement some changes, you can measure, through a transect, you can measure those changes over time. Inventories is often like taking a temperature. You're out there, you take an assessment, you can see what's going out there today. To get a fuller understanding of that site, you probably would have to do an inventory several times during the year because of the seasonal changes. You can measure some restoration and management, conservation efforts. I think that's it. Were there questions in the chat? Should we take questions now, or do you want to keep going?
I was just going to ask you, Juanita, what do you prefer? Because we do have a question from Michael Chamberlain.
I guess if it's only one, go right ahead.
Okay, Michael is asking, is this or a similar assessment used by the Nature Conservancy?
I know that the Nature Conservancy has several assessment methods. I do know that they do use this method. It probably depends on the state. I do believe that, like, for example, Missouri, I know the Nature Conservancy was very involved in developing the database for the state of Missouri. I think there probably are several others. But when you think of these assessment methods, you have to think of these belonging, they're part of a toolkit. So the Floristic Quality Assessment certainly doesn't measure everything in a natural area, but it does, it's especially powerful when you're trying to look at the floristics of an area. So I'm not all that familiar with all of the assessments that the Nature Conservancy uses, but I do know that they use this one.
Oh, I'm Jerry Wilhelm. I'm a botanist with the Conservation Research Institute. And we conceived of the Floristic Quality Assessment system back in 1970. You want me to going to tell that part?
Yeah, you're up, Jerry. It's your turn.
Okay, so we developed it. What happened was, on January 1st, 1970, the Congress signed, or the president signed, the National Environmental Policy Act. Americans, particularly after reading Rachel Carson, had become convinced that our relationship with the land and the earth, the air and the water wasn't all that cool. And we were looking for ways to take another look at our relationship with it. And one of those, of course, a powerful one, was the National Environmental Policy Act. And in the beginning of the preamble to the National Environmental Policy Act was a statement: evaluate the degree to which the impact on our area would have irreversible or irretrievable, would be irreversible or irretrievable. And so at the time, we didn't really have, that question hadn't really been asked of natural areas or open land. Indeed, most of the doctrine in the colleges and universities and the ecologists were that if you simply get out of the way and waited long enough, it'd all grow back. And that we discovered pretty early on, because we could see 100-year-old fields that while they had trees on them and some stuff, they really weren't of the quality, didn't have the fine-grained quality of a rural remnant. And so we were looking for a way to identify those areas that could be, that if you impacted them would be an irretrievable impact, and or those areas, like Linda was alluding to earlier, which had already been beat up pretty bad, and so you really couldn't hurt it. And so by 1977, we had a pilot project going where we, like Linda said, we set up coefficients of conservatism for each native species, and make that story just a little bit shorter, that runs from 0 to 10. But we discovered, she's already sort of gone into the working business of how it actually works, but what we discovered pretty early on not only for a local database, but for most of the states where we've been involved, is that if you go into an area and find the mean C of, say, well, at most natural areas or remnants that have mean Cs above 4. And we've discovered that at the industrial scale, any kind of restoration or habitat restoration reaches a kind of a qualitative asymptote somewhere around 3.2 plus or minus 0.7 at the inventory scale. Linda referred to inventories and transects, but just at the broad assessment, then if you started a restoration to restore a prairie or anything, you're not going to achieve remnant quality, which means then that any area that has a mean C value higher than 4, it will be very difficult for any biostitute who's working for a developer to claim they can build a new one, because there are no data that suggests we can do that. And so one thing you can do at any scale, whether it's if you're looking at a half an acre, an extra parking lot, that needs to be, which the parking lot to be expanded into, if that mean C, that natural area, if that area has a mean C higher than 4, it's irreplaceable. The impact is simply irretrievable. If it plays what most remnant areas, I'm sure, in around Maricopa County, you'd be happy to get mean C values of beater land up around 2. Most of them probably be less than that. And so once you start doing inventories and discover that, you'll see that, okay, most of the land is probably replaceable in some manner. We can probably even improve upon it too, if we really worked at it. But if an area is higher than 4, you have to have some sort of a moral decision, some sort of cultural decision, if you want to deprive your posterity of ever experiencing or witnessing a real piece of Arizona ever again in that area. And so that's why we started it, and that's how it's used. Like Linda says, there are a lot of other factors that go into evaluating how you might want to protect or manage or treat a piece of land. But the Floristic quality assessment enfranchises the plants so that they get a chance to say, this is how we would feel about what you're going to do. And then with regard to restorations, as Linda already intimated, if you put transects in, which are a much more sort of detailed and higher resolution assessment, within which you can pull a lot of a greater assessment as to what is the frequency or the density with which conservative species are deployed throughout the system. And if your restoration is such that every transect every other year or so is showing that your mean C is going up, and that means that more conservative species are more finely dispersed, more granularly dispersed within the system. That's also the case in some remnants. You might have a remnant that maybe has a relatively high mean C, but if you went into certain parts of it, you might find, for example, that there once been a campground there. So if you were like the White Tank Park out there, you would, if somebody had abandoned the campground 100 years from now, somebody going to go in and say, what we got here, it's going to show a low mean C. Whereas the ambient lands that have not been impacted will show a high one. So another place to build a campground would probably be where there'd already been one, or where there had been some other structure or other area that had degraded the system. So that's sort of how it's evolved. Was that clear, or probably not very clear? Can you hear me?
Yeah, we can hear you, Jerry. And then, Jerry, did you want to talk a little bit about when we incorporated the database into the FQA program?
It was clear.
Huh? He can hear you better.
What's the question?
No,
I'm losing. I keep going. The noise keeps going out.
Jerry, can you hear me?
Yeah.
Okay, so the last question was, when did we incorporate the database?
Oh my gosh. Well, the first data, I don't know, but it was after it was after the see, but when we first did this, there were no, all we had was a calculator that would add and subtract, multiply and divide. And so we had a hard time getting the same answer twice until we were able to put it into a spreadsheet. And Linda developed, along with Wayne Lampa, the first spreadsheets that dealt with it in a database. And she did that in 123, in Lotus 123, which is a very powerful program that included, Linda was able to come up with some pretty complex macros that enable us to do a lot more than we generally do today. So what she called the similarity indexes, the phenological indexes. For example, she was able to plug in, let's say, a woods that had an inventory in 1920 of a certain set of plants, and by 1970 was inventoried again and had a different set of plants. And she was able to show that the blooming date of, this is in our area, the blooming date of the plants that were in there, the average blooming date shifted back toward the spring, because as the leaves came on the trees with fire suppression and whatnot, and trees densed up, those species that bloomed in summer and fall really began to dissipate. And so we were able to show that, also able to show that when we went in and burned and opened it up and that sort of thing, the summer and fall flower began to reemerge. So but we don't do that. We don't have that. That's not easy to do anymore. But it wasn't until really the late, as far as I can remember, almost to the 1990s, that we even had a home computer with which we could even pretend to do anything. And then, so I think the first real databases, and I'm not even sure when the first one was developed, but I guess it was when was that? When it was.
I don't remember exactly, but it did evolve as demand grew, as people begin to learn about this assessment system. People wanted to incorporate it for their areas, and there was no real easy way to bring in other people's, to spread those macros around. We did develop something that was a standalone computer program before this calculator came about, that we were sort of clumsily able to incorporate some other databases. But it wasn't until Will Freeman came along with his amazing skills that he was able to develop this Floristic quality assessment calculator that allows anybody to upload, to develop a database following certain guidelines, upload it, and begin to use it. So it's just, as I said, now there are 70 databases spread out throughout North America, the United States and Canada. And it's just, just wonderful. So that's where we are today.
Thank
The most recent database being Maricopa County. Yay.
Yay. Yay. Steve Jones, are you on? You're up. Steve and Kara, you guys are up.
Okay. I don't know. Kara, are you there?
I am, yes.
Okay. Yeah. Well, let me see here. Yeah, that looks good. We did meet 8 times, Jeff, about 8 hours each. I remember that.
Let me just let me just put that in context. So Steve and Kara are going to talk about, so Linda and Jerry both talked about how the FQA came to be and why it was invented and what it's used for. And now Kara and Steve are going to talk about how our team, the collaborative team that Ariana introduced at the beginning, put together this Maricopa County database for us to actually use this universal FQA. Go ahead.
Okay, yeah, we met about 8 times, 8 hours each. We used SINET for the nomenclature, Southwest Environmental Information Network. It's been going for, gosh, I don't know how many years now. ASU has been the core of it, but right now it includes just about every herbarium in North America and quite a few outside of North America, actually. Well, mostly North America, should say that. So we have, Mexican, Canadian, well, not Canadian, that's right, but all over the United States at least. So we have access to, herbarium records from all over the country and map locations and things like that. We went through, gosh, I don't know how many species of Maricopa County plants we went through. Do you remember, Kara or
It was
Juanita?
at least a couple thousand, wasn't it, Juanita?
That's
I think we started at about 2,800 and we dwindled it down, and I'll talk about that in a couple of slides. Yep. Mhm.
okay. Yeah. We did have to
158.
work through quite a number of them, and work through some nomenclatural issues. But there are some within SciNet and some that we just had to straighten out. Between that, SciNet, Flora of North America webpage, that was very, very helpful too, that we worked through basically each species and had to wrestle down in a C value for each one of those. So that's pretty much the process. Kara, do you have anything to add?
Yeah, we basically met over Zoom several times, and we spent a few hours each time, most of the day. Yeah, 8 hours it says here, so that's probably what it was. And it was really intense. There were, 5 of us. And we all come from different backgrounds, and we all have different experience with plants. So it was really interesting to come together with others and get everybody's input. And we learned so much too, I think, by doing this process. We learned from each other. We learned where SEI needed to be updated. We learned about gaps in knowledge, that we could do research projects for years. But it was an intense process, but ultimately, yeah, we came together and we hammered out those C values to the best of our ability. And it was, it's really cool to see it finally launching.
Yes, it is. Applied it to some riparian areas that the Desert Foothills Land Trust has. We have species lists for them, so I'm able to come up with some good information for the Desert Foothills Land Trust to use.
Cool. Yeah, and we're supposed to talk about this slide too, correct? Okay, so I would say, yeah, probably our biggest the biggest problem for us was getting, because as conservation biologists, if you will, or we have rare species in Arizona, and we have it's hard to get your head around the conservatism idea instead of thinking about how rare something is, because it was a little bit different. And I know a lot of times we had to remind each other, okay, it's not about it's not about how rare it is, it's more about where it grows, whether it's weedy or not in its habitat. So or whether you're going to find it a bunch of places or you're only going to find it in a very specific area. So in a remnant area, if you will. So it was that was probably our biggest challenge, is staying on track with the goal of what the C value exactly supposed to help people decide. Anything to add, Steve?
Not really. That was interesting. Just trying to, you hear a rare species, and you say, oh, 10 right away. And then you think about it. No, it's not really. There's some things that are very common, but that are very specific as to their needs. And we had to, basically look at that and say, well, that number needs to be higher, just because of that fact. So it was a bit of a wrestle, as I said. So, and here we are. We have a database.
Did you guys want to talk at all about the difficulty of the aquatic species?
Yeah, I mean, I remember that there's a lack of information for sure. We definitely struggled with this too, because riparian habitat in Maricopa County specifically is gold, right? So yeah, we struggled because of the particular habitat, but then we could also have weedy plants in that habitat, but that habitat is rare and remnant, and so yeah, we had a really hard time there. And
yes,
go ahead.
I was going to note that there's very little above ground water flowing in the state of Arizona. It's mostly intermittent streams left, and the longer we go here, the more intermittent they get, which because of, of course, urban uses and groundwater pumping and things like that. And damming, of course, changed a lot of the rivers. There's not much in Maricopa County in that regard. There's Salt River dams, but Salt River through the city of Phoenix was particularly interesting. We had some good information on that, species lists and what have you, and we're able to work with that. But it was a bit tricky on the aquatic species.
That's great. Thanks, you guys. I really appreciate your comments about learning things as we went along. And so just for those of you who aren't there with us in that room, so it did, SciNet nomenclature had to be updated, intensely. So we kind of did a combo of updating the SciNet nomenclature from the flora of North America, as well as create this FQA database. Linda and Jerry talked about, what we can use this for and how it involves. And then Karen and Steve talked a little bit about how we developed the Maricopa database. But I did just want to mention that these FQA-based habitat measures have successfully emerged as a bridge between judgment-based and quantitative assessment. And it's really widely used and is highly influential, especially in North America. And it's increasingly being relied upon to guide ecological policy, regulation, conservation management, and research. So really important, and I'm glad you guys all are here to join us to learn a little bit more about it. We are the first county and the first area in the state of Arizona to develop a database, but I don't imagine we'll be the last once people learn about what you can do with this. And so I'm going to talk about some practical uses for it moving forward and show a little bit about how you guys can actually use this database. So the webpage universalfqa.com is the site where the calculator is kept at and all these databases are stored. And that's what I'm showing on my screen right now. And once you just sign in, create an account, just like you would any other account to get an account started. And so then when you go in and if you click on this FQA database on the black bar up here, this is what pops up. And so this is just a short list of what I could fit on my screen of some of the databases that are in there. If you scroll down to M, that's what you see on the bottom right here. So that's the Maricopa County database that we created in 2021. And that has all the information that you need for your assessment in Maricopa County. So once you're in there, you can do, basically what you can do with that assessment is you could view it, which is where this yellow arrow takes you, and it pops up this really nice report that you can download. It's really pretty. It gives you all your parameters, and then it has the list of all your species with all of the metrics. Or you could download the CSV species list. And so this is the entire species list for Maricopa County. And the reason you would download that is so that you can compare your list and make sure you're using the proper nomenclature as the ones that we use to create this database. And then, so Steve wanted to know how many species. So the total number of species was 1,589 for the county, with 1,256 of those being native and 333 of those being non-native species. Now that will change once you guys all start using this, and you're going to find some species that we missed, and it's going to happen. But I would ask that once you guys start using this, and if you can't find your species right away, go to SciNet, type your species in and check to see if you're using the right species. Because if you put it in SciNet, it'll pop up, it'll convert your species to the right cinnamon when you do that search. So I'd ask that you do that first, but I do expect to have a new database in 2023 where we add any of the species we might have forgotten. So Wendy, Kara, Danica, and Steve aren't done with their work yet. So I think what we'll do is I'll collect those and I'll send those to them to get together and score and evaluate and give a coefficient value, and then we'll add a new database. So how can you create your own inventory assessment? What do you have to do? It's pretty simple, but it does help to have someone walk you through it at least one time in order to do it. So once you create your account, you go in there, and this black tab originally went into the FQA databases. Now we're going to go to the assessments, and we're going to select new inventory. And this box right here that says new inventory assessment will pop up. And so you need to select the FQA database that you're going to be using, which in your case will be the Maricopa County database. Now you can only use this in Maricopa County. You know, if you're in Pima County, I'm not saying this wouldn't be somewhat accurate, but you'd want Pima County to create their own database before you're going to use that one. So this is the new inventory assessment sheet that you guys will fill out. And Linda was so kind to create a 10-minute video that's going to show you exactly how to do this. So I'm just going to touch up on some of this, but that video will show you in more detail. Sorry, one second. So you'll add the month, the day, and the year. The assessment name is the name of the survey that you're going to, whatever you want to name it. So if I did White Tank, I would put White Tank Mountains in here. The practitioner is you. You can add latitude and longitude, and that's pretty simple to do by just going to Google Earth and dropping a dot, dropping a point right where you want, in the middle of White Tank in my case, and then getting the X and Y coordinate, which is the latitude and longitude. And then you can add all these notes. You do have to select a site, and Linda talks about that in the video, so I'm not going to go into a ton of detail on that one. But I did want to show you, so this is the bottom part of that form of entering, and I did want to show you how I entered the data for the parks when I did it. And it has to be a CSV file. That's so important, because I don't know, if you try to do Excel, you're going to keep getting all these red exclamation points, and you're going to be like, how do I do this? And you're going to get frustrated. Just remember, you really do have to put it in as a CSV, and to convert an Excel to CSV is save as, and then just select the CSV file. I put ours in using the acronym, and what an acronym for the plant is basically the first 3 letters of the genus and the first 3 letters of the species. Now there is some exceptions to that rule, but for the most part, that's what it is. If it's a variety or a subspecies, the 6th letter will be the first letter of the first letter in the variety. And sometimes there's duplicates. And so I think then it takes the 4th letter is that one instead of the 3rd letter. So I don't want to confuse you guys, but it's pretty simple. So you can take this and you can go right here and you can say choose file, and then go get this file and upload it. And it's pretty easy to do it that way. If you have your database, what I would do is I would make sure your acronyms all match from your species list, and then copy and paste it into a new worksheet and upload it that way. You can also put a comma next to each one of these and load it this way where it says add species. And you can do it by scientific name, you could do it by the acronym, or you can do it by common name. And that goes for choose file as well, but you want to make sure that it's accurate. I recommend doing that acronym because less chance of mistakes and accuracy. So here's just an example of Buckeye Hills Regional Park and what that fancy nice report that comes out when you download the report, or when you hit the view button, and then you can download it. And that's what I did here. And so it gives you all the metrics that you enter. If you put weather notes and duration notes, the community types, and then it gives you all your conservatism metrics in here, such as, and these guys have been talking about these numbers, and maybe you guys haven't seen these and didn't understand when they were talking about them, but here's the total mean C for Buckeye Hills is 5.7, and the native mean C is 6.2, and the total FQI is 68.9. It also gives you species richness. Now I'm going to talk, Linda was mentioning the species wetness for the state of Arizona, the wetness value, I couldn't find them. I mean, I couldn't find most of the species that we had on our list on the national list that's available. And so I don't think anybody has gone and actually scheduled all of these. The physiometrics, let's just go with that. It also gives you all that. So everything on here is pretty accurate, but the species wetness isn't very accurate, because if you look down here where it says W, most of those are non-applicable. So until we get that data and that information in there, the wetness value isn't going to help very much. Okay, So here's the beef, the juicy stuff. This is a comparison of the park's FQI. And so kind of what we're looking at here is the native FQI and the native mean C. And what's important about this is, and the native mean C basically is the mean coefficient of conservatism of native species present. So basically the average of all of the species that are out there. If you only look at the FQI of a park or any area site, then the size of the sample area will influence the values because species richness generally increases with the size of the sample area. So mean C, how it's more immune to biases related to the sample area, at least plot, community, or site scales. So kind of the takeaway here, and I'll just kind of point a couple things out. So the White Tank Regional Park has a really high FQA, 128.5, and a native mean of 6.7, which is really high. That's a really high quality site. But if you look at Cave Creek, that's so White Tank is 30,000 acres, and that's huge area, and it should have a lot of. Sorry, Jerry's calling me. I don't know why. Linda, can you call him? So it should have, it should have a high FQI, but 128 is really great. So Cave Creek is only 3,000 acres, and it has an FQI of 58.5, but it has a native mean C of 6.9, which is actually higher than White Tank. So basically what that's saying is it has more high quality or more conservative plants in that area for the small area that it is, right? So it takes out the space. And so that's really important. And Jerry really wanted me to find a degraded site to put in here for you guys to see what the difference is, but I didn't have any, and I couldn't find anything on SciNet of a degraded area. And so all of them are mostly high quality areas that have had their floristic inventories that I was familiar with. So I popped in Papago Park. That's not one of Maricopa parks, but I wanted to put it on here to see if, it was degraded since it's such a heavily used park, but it actually still scored really high. So what Jerry was talking about before, a restoration area, you can never get that C value of, I think he said the isotope was 3.2 plus or minus 7. So it'll never be a 4. But what we have already out there in nature is already a 4, and it's worth saving and preserving. And so this is really a good metric. And I just want you guys to understand, why we would use this and what we would use this for. And so I'm comparing the parks. And one of the reasons why I'm comparing the parks is because I want to know which sites we need to put our dollars in, the higher quality sites, right? And so that's kind of what we're going to do there. And in addition to comparing sites like that, but you could do the same thing with land acquisition. If you had a set of parcels, you can go do a floristic survey, upload them here and compare them. You could run the same analytics that we just looked at. So a mean C comparison. So why is this important? So basically what we're looking at here is the native mean C versus the total mean C for each of those parks that I just showed you on the last slide. And the light green is the native mean C, where the dark green is the total mean C. And why is that important? Well, a difference between a native mean C and a total mean C, if it's greater than 5, suggests that native species have become compromised by non-native species. So I wanted to see if any of our parks were compromised by non-native species. And what we found was that White Tank Regional Park had a difference of 0.06. Well, that's a long way from a 5, isn't that right? And then the Hacienda River Preserve, which was the one that had the most non-native species. If you look at that right here, it's 4.8 to 6.1. So that's a difference of 1.3. So that's our park that's the most disturbed, I guess I would say. And so that's a good way also, to measure. You could probably use your transects and measure that over time. And you would think that as you, and I did want to talk about that word restoration too. So when Jerry and Linda were talking about restoration, that is severe degraded land, meaning, they turned it into an agricultural field or they built a campground on it or something to that effect. Community enhancement, on the other hand, is when you have these high quality areas already and you are doing some form of community enhancement to them. And so I just want to clarify that too when we use that term restoration so loosely. And so then here's the species nativity, non-native versus native for each of those parks. And I really just wanted to throw this slide up there so you guys can see that you can use this as a comparison. And so, you know, White Tank, we have 368 native with only 39 non-native. That's pretty great. Whereas some of these other parks, they're higher, like Hassayampa River Preserve has a lot of non-native species, 80 to 273. So that percentage is much greater. And so it is a high quality area, and we would want to do some work there for sure on invasive species. Okay, we're going to compare changes over time. And I will tell you, Jerry helped me with this one because although I can pull some of these parameters, he put it in this really nice graph on the right. And so what we're looking at here is the White Tank Mountain Conservancy's floristic inventory that was done in 1973. And then we had the Desert Botanic Garden hired some folks to go out and do another one in 2020. Actually, it was 4 years, but they finished in 2020. And so what we did was we pulled these up. We ran the floristic quality assessment on each of them, and then we compared the differences. And so in 2020 is the orange, and 1973 is the red, just so you guys can see that, for instance. So what has changed? And let's just put this into context, is there's been no severe degradation to this park. It's been conserved for this entire time. So the only changes are effects of just hiking and biking use, and then climate change. And so that's the only thing, that's factors that are really affecting these numbers. And so we've seen 23% fewer native species. So we've decreased by 23% of our native species. Our mean C has decreased by 3%, and our FQI has decreased by 15%. However, our non-native species have increased 20% upward. Jerry, I don't know if you want to talk a little bit about that coefficient of similarity. I'm going to let you do that right now if you'd like to.
All right. Well, the coefficient of similarity is the formula 2C over A plus B, where A is the number of species in one site, and B is the number of species in the next site or the other site, and C is the number of species in common. You multiply that times 2, divided by the sum of the two lists, you essentially get a percent similarity. Well, this is at the inventory level, this is a really hard thing to deal with. But generally speaking, if you go into an area and several different people do it on a pretty good, at the same sort of level of inventory, you're both going to get about the same mean C. And so the fact that we've lost 2 points is actually at the native mean C scale is actually fairly significant. Generally, we don't get that kind of drop. It's hard to know when you also, I should say that when you have, even though the similarity is only 77% over the 50-year period, that means that the flora, that you could presume from that the inventory, that the flora has actually changed. But we see this all the time. We've seen the same site, the same acre change, have a different coefficient of similarity 25 years later of sometimes only 60, 70%. So in a single inventory in a single year, it's very, very difficult to come up with the same species set year after year, or even whatever. And so, however, it does seem as though that when you drop the mean C by 2/10 and you drop the inventory or the FQI by that much, that suggests that there's actually been some trauma to the site. It also could mean that the person who did the inventory in the latter part of the 50-year period, since there are more non-native species, that person could have spent more time around the campground than was originally done, or the campground may not even have been there, and so the weeds may have been more broadly dispersed. So all you can do is look at what you've got, but I wouldn't draw too many conclusions from it. Having lost, however, 23% of our native species, if the inventories were of equivalent intensity, that's probably a pretty intensive drop. which sort of goes along with the drop in the mean C. But generally speaking, the means in a healthy system, we've done a study where we did transects and inventories every year for about 25 years at a site in Indiana, and it didn't change at all at the mean C level or the inventory level for those sites over that 25-year period. And so even though the actual similarity of the plots would change rather dramatically from time to time, the qualitative metrics did not change. And so this is a little worrisome. I don't know, you'd have to look back and see, was there a campground there in 1970 or?
I think you hit the nail on the head on that one. The campground probably wasn't there at that time, but I'd have to go back and look.
Look, the survey guy was living in a tent at the campground when he was not doing inventories because it's a big area. Then he's going to make up more weeds than somebody.
And it might be it might even be that we added some new campgrounds since then, and I know that we have, so that's quite a possibility as well.
So generally speaking, though, just so the audience knows, is that in a healthy system, one that's not being damaged, the mean C usually stays about the same over the course of time, might drop a tenth of a point or go up a tenth, but that's even rare. Of course, our sites are relatively small. A site the size of White Tank is kind of huger than anything we ever get ourselves into. But the quality metrics, I should say, are far more stable than the actual species inventory metrics. We could go into a site here in Illinois, for example, and after 3 years of not burning, the index might drop because we don't see as many species, but the mean C will still probably be about the same. So it's useful in helping determine the how stable your system is, and you want a stable system. That's your goal, is to achieve whatever stability, whatever mean C level you have. I will tell you this, that we haven't seen in a site that's in the contemporary era. We haven't seen the mean C move up beyond what our initial assessment was. So whatever damage has been done since settlement is usually pretty permanent. We don't see the mean C rising. That's unfortunate, but that's just the way life is. It's just like a plane crash. Once we've done damage to a system, it's largely permanent.
Thanks, Jerry. I appreciate that. So this is just some continued metrics of that same two studies, 73 versus 2020. And just the take home from this slide is pretty much everything in orange is less than everything in red. So it's changed or decreased, except for apparently we have one rush that joined us since 1973. So, and I think we already talked enough on this topic. We're gonna show you a 10-minute video on how to enter the data into the universal FQA that Linda put together. It's super, super helpful. And then right after that, we'll go to questions. So let me.
Juanita, I know you mentioned the video. I think we'll have to have a hard stop at 6:30. There are some questions in the chat. Do you want to talk about them first, or you prefer to wait after the video?
Let's do the video first, because it might answer some questions. I'll just copy this link. And we'll go with questions. I'll copy that link and put it in there for you. I can't do it right now while I'm on the.
I'll put it into the chat for you, Juanita, and then I'll also make sure that link goes out to everyone in the follow-up email. So if you guys do miss it in the chat, you can catch it at a later time.
Thank you, Ariana, for doing that.
Yeah, no problem. So I think the question of nomenclature did come up. And I don't know, Jerry, if this is the one that you may have already answered, but just scrolling back up, Michael had asked, does the database continue to update with ongoing nomenclature changes?
So can I talk about this for just a second? You can, I believe you can you can add to your current database, like if you're missing some species that need to be added. But if there's a wholesale change in nomenclature, for example, Jerry wrote the book, The Plants of the Chicago Region, and I don't know what year that was, 1990s. And then a recent edition came out. There were some large changes in nomenclature. So a whole new database had to be uploaded. And both of those databases are still there because some people have done assessments in the first one and some people are doing assessments in the second one. So it sort of depends on what the changes are and how many there are. If there's just a few, you can probably modify your database, but if there's a wholesale change in nomenclature, you need a new database.
And basically the changes in the database are the year. So that's how you know. So you use the most recent version of that database. That means it's the most updated. So when we put a new database in next year, we're probably going to call it Maricopa County 2023. And so that's how you'll know.
Thanks, everyone. Kathleen also asked, do we want the land to have a mean C higher than 4 and the same for a specific plant?
I think it depends on what question you're asking and what you're doing.
What was the question?
Kathleen asked, do we want the land to have a mean C higher than 4?
Well, if you're into restoration, you set your goals, but certainly you may not have been here when I was talking earlier, but generally speaking, the mean C of a remnant landscape is higher than 4. Most restorations, particularly at the industrial scale, rarely achieve mean C values higher than 3.8. So whether it's more than 4 or whether it's 5 or 6, the sort of the operational rule, if you will, or the operational fact is that if you damage an area that has a mean C a rate of higher than 4, you are doing something irreparable to the landscape. And so your politicians and your village engineers and developers and people should know that if an area that's under question has a mean C higher than 4, they need to understand that no restoration effort can mitigate that. So that's sort of that line. That's where the 4 has some meaning. And in a restoration, like I mentioned earlier, the best restorations will receive it. Will at the inventory scale will receive a mean C of 3.2 plus or minus 0.7, which means you're 95% confident you can't approach a natural area in a restoration effort. So that means that de facto you can't replace a remnant. That's just a policy, an understanding that people have to have if they're developing policy about land uses in the area. And then you will eventually have data to show that, because a lot of the land around Maricopa County will have mean Cs in the, in the urban area and suburban area, probably lower than 2. And those areas have already been damaged, and you can wait till hell blows over and they won't go back. They won't accrue much higher. Even old fields around here that have been fallow for 100 years rarely get mean C values higher than 3. So there are a lot of reasons for this, but a lot of plants also are dependent upon an array of insects and a whole other host of environmental and ecological factors that disappear when we damage the land. So most of our conservative species don't have the sort of other biological infrastructure to sustain themselves in the system, even if we plant them there. So if you were to plant in a restoration a guild of plants that has the seeding list itself would have a mean C, say, of 6, you're still not going to get higher than 3.8 because the system just, the damaged soils, the lack of other organismal infrastructure to support them just isn't there anymore.
Thanks. That was very clear.
We've got another question from Michael. It says, what C value damage do you see from a wildfire in the Sonoran Desert?
I've never seen one in this.
We haven't run those types of analysis at this point in time.
What can happen locally in the Chicago area, if you burn an area that hasn't been burned in a long time, but should be burned, that down fuel over years can actually scour the land. For example, where they're burning in some areas every 3 years, we've wiped out the lichens. If you burn every year, the lichens will sustain because the fire sustains above the lichens and the heat goes up. So the annual autumnal fire was the pattern here. So you're going to look at what the Aboriginal patterns were out west. I suspect it's greater than what people think today.
Who asked that question?
What's that?
That was
Question, Mariana.
Michael Chamberlain.
Michael. So Michael, that would be a good way to do the transect surveys that we were talking about. But you'd have to do it before the fire came and then after, and then do it for a few more years after that to come up with that. But we don't have that. Like we just developed this database. We're just rolling it out to you guys right now. It hasn't been used in the state. So to compare it to what happens in any other type of habitat or ecosystem isn't even fair, because other ecosystems are fire adapted where the upland desert habitat is not.
We have a comment from Elena that I don't know if you'd want to speak to, but she says, it seems like we need to identify a range of mean Cs for reference sites around the county.
I'm not sure what she means by that.
Kind of similar to what Michael was asking, right? We don't know what happens to the mean C during different events in the county. So maybe even just looking at a place that has burned compared to a place that hasn't, or urban areas, remnants versus smaller urban remnants versus larger urban remnants, all kinds of things like that.
Yeah, that sounds like a good plan. A good use of this.
Well, you now have a tool to find out. You
Great.
can find, that's one of the advantages, that you can determine whether the fire, either regular or infrequent, is having a positive or negative impact on the natural biota of the site. That's just research and local familiarity with the landscape. But you now have a tool you can do that with. Thank you to the Central Arizona Conservation Alliance and others.
All right, we've got another question. If a site has a specific low mean C value and the site is scrubbed for development, would we want to restore the site to the same level, or should we shoot to go higher if we can?
Like I say, you can shoot for whatever you want, but you're not going to achieve a remnant quality. And so that's just a sad fact. This is why your politicians and policymakers should understand, if you have a piece of remnant in Maricopa County and you kill it, it's dead.
I know,
forever.
but Jerry, I think she was saying, like, if it's a low quality below a 2, try to restore it to develop it like the surrounding area. That
Absolutely. If you can bring your system up somehow, I don't know how you do it down there in Maricopa County, but get the C value as high as you can get it, and get it to a stable circumstance. That's your goal. And then who knows, over the long course, if you do this enough all around the county, there may be, in the long term, if you preserve the natural lands around Maricopa County, there may be the possibility at a much broader time scale where something could happen. We just haven't seen it yet. But certainly you want to do the best you can to achieve. Also, though, I should say this, and Linda would probably agree, if you go in and plant things in little pots and water them, that's not the same thing as actually being there. So what you're interested in sustaining isn't the plants you put in there, but their children. And so if the system can't hold the seeds, can't hold the new embryos, can't hold the new plants, and can't sustain to make new generations, then they're not really there. And so you could plant, people have done that in the Chicago region. They've gone out and planted high C value plants in their restoration, and there they sit and don't go anywhere until they die. But their children aren't making a new tomorrow there. And that's really what you're trying to achieve, is a system that has the internal diversity and system integrity to make itself new again every year and sustain that quality. So you want to reincorporate the whatever patterns the native people were using, whatever patterns were aboriginal to the area. Those are the sort of abiotic strategies that you need to re-engage in that landscape that into which you're planting or putting or entreating to grow native plants of the area.
Do we have any other questions?
Juanita, if you use the insert button up there at the top, it says insert, you can insert a video under pictures, I think. Go under pictures. No. Oh, I'm sorry. On mine, you can insert a video.
We'll make sure the link goes out to everybody.
Okay.
It's further out to next to audio media.
Where is it?
It's on the
right
board,
here.
but over by media. Yeah.
Oh, there. Insert from this device. Yeah.
I have to have it downloaded on my computer then?
Oh, you don't have the,
No,
don't
I
have-
just, no, I don't, sorry.
okay. All right.
Okay, that's okay. Everybody if you really want to know how to do it, it's a really great video. I'm sorry, Linda.
That's okay. It's detailed. I mean, it shows you different things that, you know, but you can explore the FQA calculator on your own. It's actually pretty easy to move around in. You can look at every single public assessment that's ever been done, but I just want to warn you that it takes a long time to load because there are thousands of them. There are FQA questions. All the calculations are in the help feature on the top bar. So if you want to know what the calculations are for both the general inventory and the transect, all the calculations are there. So those are some things I think that weren't talked about. So.
Cool. Like I said, it is in the chat, but I'm also going to send out an email to everyone early next week that includes the link. I just tested it on my computer and it looks like it works really well. So we'll make sure to get that to everybody. And then Linda and Juanita and Jerry, are you guys, would you like your contact information to also be shared in that email? Are you comfortable with that if folks have questions? Okay.
I'm fine. Sure. Absolutely.
Sounds
Okay.
good. So then, yeah, everyone who's here and everyone who registered, you'll get an email from me with some contact information for these folks, and then a link to the video as well. So if you are interested in exploring and you have some questions, that you can do so readily. But thank you so much to all of you. I think this was super interesting and I loved seeing the conversation in the chat and the questions. I think people are really excited about this. So thank you so much for coming and sharing with us tonight. And thanks for everyone who attended and asked questions. This is really wonderful. So I'm actually gonna stop recording now. And I think people can head out for the night and expect that follow-up email from me on Monday to everybody with the information.
Thank you guys all for helping with the FQA. Linda, Jerry,